record on this computer. Okay. Before I start again with the new topic, actually it's not the new topic, but I will continue discussing with this one. But for yesterday's topic, anyone want to ask question? Yeah. Okay. For this the topic that we already discussed yesterday. Okay. Anyone here want to ask question? This is all the things that we discussed yesterday, but today I will discuss very new things. Okay, no one? Okay, in that case, I think I will check your picture one by one. Okay. Rizky Dasa, you hasn't uploaded your
Yes.
Profile picture yet.
Huh? I think I have.
Oh, okay. Most likely in that case, then I'm not sure why it's not coming up in my screen. Ahmad Sofyan.
You haven't logged in, bro.
I think I logged out, but yesterday in my account I have uploaded.
Okay, in that case, it's better for you to log in now then.
Yeah, I think today I log in as a guest. Maybe I should play first.
Yeah, it's great. You leave, okay. Then log in again.
Okay.
Okay. Ahmad Sofyan, is it the same case for you? Hello, Ahmad Sofyan. Sunita Hugh, most likely it's the same case for you as well. Pai Satya as well. Adiatma as well. Okay. Rifki Sakif here is it my assistant? Is it Rifki Ahmad? Hello, Rifki? Okay, so for those who still hasn't logged in yet, it's better for you to log in order for me to be able to see your face, at least from the picture. Okay. Then let's start the class. Okay. If none of you have any question about the previous topic, then I will continue with you, and I will remind you again. I'll try to slow down as I will try to match with your speed. So whenever you have any question about the topics that I'm talking about, please let me know. Okay, it is better for you to do that than you try to catch up later, because all the topics in statics, it will be a continuation. Okay, the first chapter, second chapter, third chapter, and so on, it will be a continuation. So never think that if you can skip this chapter in order for you to catch up later. No, it is better for you to do it in sequence. And whenever you don't understand, ask me directly. Okay, in order for me to make sure that you can understand completely.
Okay, sir.
Okay then. In that case, I will continue with the today's discussion. We will start with. You want it as quiz or as just a practice session? It's up to you guys. You need the quiz practice in the morning in order to wake you up.
Just practice, sir.
I think a quiz in the morning is good.
Not ready for grade.
I think practice is better, sir.
Practice, sir.
Oh, practice is better. Okay. Why?
Exactly,
I believe quiz in the morning will wake you up, right?
Yeah, but it will make our grade red.
Exactly, sir.
Okay.
Which is not good for our
It's kind
score.
of double-edged sword.
Okay, then in that case, yeah, I will not make it as quiz, but please try to do it now. Okay, so this is the things that I want you to try right now. So please take out a piece of paper. It is not a quiz, but try it by yourself. You can use your if you are some of you maybe prefer is preferable to for yourself to use a piece of paper and pen to practice, or the others maybe prefer to use a tablet or something like that. It's up to you. But I want you to try it right now, not just by looking at the screen, but try it directly. Okay. If any of you don't try it, okay, I will replace it directly to a quiz. How about it? Okay. Fair enough, right? Sig?
Yes, sir.
Hello, Sig.
Yes.
Is it fair enough for you?
Yeah, I think it's fair enough.
Okay then. Yeah. Now, so try it now. Try to understand the problem first. Then try to use the things that we discussed yesterday to solve this one. Remember that the moment is f multiplied by d, where d is the perpendicular distance. Okay, try now.
I'm sorry, sir. Can you repeat the last part?
Remember, the last part is the things that I explained to you yesterday, Mary. Okay, Mariel, okay, Mariel. In order for us to
Thank
get
you,
the
sir.
moment, the one that is us here is the moment. Moment at point O due to the force 600 Newton, right? So remember, yesterday I told you that how to calculate the moment. Okay, the moment is supposed to be the force multiplied by the perpendicular distance. This is just a scalar calculation. You don't have to calculate it using vectors. Okay, this is just a scalar calculation. So perpendicular distance multiplied by the force, or the other way around, because it's scalar, so it's supposed to be. Okay, you get it, Madam?
Yes, sir. Thank you, sir.
Hmm.
Yes, sir.
Okay, because I will give you time to think about it first. I will pause the video, because if I don't do that later in the video, it will be too long and it will be too boring. Wait. Yeah, it's been 5 minutes already. The first question that I want to ask about is, do you understand the problem, alright? Matthew, who?
Yes, sir.
Do you understand the problem?
I do, but I think I'm still sleepy. I got a lot of answers.
What do you mean? A lot of answers.
It's actually my mistake.
What do you mean by your mistake?
Until now, actually, I don't know which one is my correct answer. I got like 3 different answers.
Okay. Yeah, we will discuss about that in that case. But you got the problem at. I mean, you understand the questions at least, right? Okay. Anyone here don't understand the question? It's okay for you to tell me about it.
In my case,
It's
I'm
a
not
matter
sure.
of if it's
One by one.
It's kind of hard to interpret, sir.
Okay. What do you mean? Hard to interpret?
Like because like first of all, it's we have to like do it in 5 different ways, and it's like we're not sure like where to use the cross formula
Okay.
or the
In 5 different
distance.
ways. Sorry. I forgot to explain to you guys. Just ignore the 5 different ways. Try to use the way that I told you guys yesterday.
The perpendicular distance, then, sir?
Yes, perpendicular distance. That one. Okay, but you get the problem, right? We have to find out the moment which is happening at point O due to 600 newtons, right? Okay, I believe it's not supposed to be a big problem. So now the next question is, yesterday I told you guys that we have to find out the perpendicular distance, right? Okay. In this case, what is the value of perpendicular distance? Anyone can help me with that? Anyone here?
The
Perpendicular
distance
distance.
19 the distance with an angle 90 degrees from the line of action.
Yeah, it's supposed to be. So when we talk about perpendicular distance, it's become a geometrical problem. Okay, that's why what we're supposed to find out is this one. That is the distance, the perpendicular distance, because we have to make sure that the distance here will, sorry, the angle there is supposed to be 90 degrees, but here it's supposed to be 90 degrees.
Yeah, so
Okay.
because of that, we use the 40 degrees, right?
Yes, correct. You're supposed to use the 40 degrees. Anyone here able to solve this problem?
I'm not sure, sir, about my answer, but I think I got it.
How? What is the value that did you get?
I got 1,838.51.
No. I mean, I want you to give me the value of the perpendicular distance first.
4 times cos 40 degree, 3.06.
3.06.
Yes.
You sure about that?
Sir,
In my calculation, yes.
Sir,
Mm-hmm.
I'm pretty
Okay.
sure the answer is 2055.51.
2055.51. Okay.
Yes, I have
In
the
that
same
case,
answer as well.
let's discuss it together. Okay. Okay. Let's discuss it together. So can we agree on
sir,
the drawing is supposed to be like this, right? The D is supposed to be like this. Correct or not?
yes. So we have to use sin and cos both.
Yep, correct. So, okay, let's discuss about this bit by bit. Okay, okay, the angle here is supposed to be 40 degrees, right? Yeah. Why I reveal the answer? Okay, I will not reveal the answer first. Okay, so the angle here is supposed to be 40 degrees. Okay, then because it's become a geometrical problem, right? Okay, and then we know that from the picture that the perpendicular distance here is supposed to be 90 degrees, right? Yeah, this particular line is supposed to be 90 degrees to the force, correct, right? Correct or not?
Yes, sir. Yes.
Okay. And after that, if this one is 40 degrees, this one is 40 degrees, then if I draw another line here, it's another which is perpendicular to the previous line. This angle is supposed to be 40 degrees, right? Can we agree on that?
Yes.
Okay. How about the rest? Can we agree on that?
Yes, sir.
Yes, sir.
Sir.
Okay.
Sir.
Then there are several triangles there. And you see several triangles there. The first triangle is this one. This is the
Yeah, that
first
is true,
triangle.
sir.
Yeah. The second triangle is this one. Okay. The small one and the big one. This is the big triangle. Okay. And this is the small triangle. Can you see that?
Yes, sir.
Yes, we can, sir.
Okay. Now, can you find out the perpendicular distance, the total perpendicular distance D from those two triangles? Because all the
Yes.
angles there are unknowns. Okay. Try to do that and recheck again with your answer. Okay. Because if you see, right, okay, D here is supposed to be this one, this length, okay, plus this length. Correct or not?
Correct, sir.
Yeah. So if the first red line there, I call it as D1, this is D2, then D is equal to D1 plus D2. Okay. Try to find out what is the value of D1 from the first triangle and what is the value of D2 from the second triangle. Okay. Let's see it together. Okay. This is the first triangle. Okay. And this is D1 and this is 4 meters. Correct, right? And what is the angle here in the first triangle?
50,
50. Why 50?
because there's 90 in the left one is 40, so
Okay.
must be 50.
So total is supposed to be 90 degrees, right? Because here it's a 90 degrees. It's supposed to be 90 degrees angle. And from the first triangle, it's 40 degrees, and the part which is belongs to the the parts which is belong to the second triangle is 40 degrees. The parts which is belong to the first triangle is supposed to be 50 degrees. And this one is supposed to be 50 degrees. Can we agree on that?
Yes, sir.
Noki. Hello, Noki.
Yes, sir. Yes.
Do you understand this, Noki?
Yes, sir. I understand.
Okay, good. Then we have 4 meter with D1. We have 50 degrees. Okay, and remember, here it's 90 degrees. Because from the beginning, we create the line in order to make it as in order to make it 90 degrees, right? Now, what is
Yes,
the
sir.
value of D1 then? If that one is 90, if this one is 90 degrees, then this one is supposed to be 40 degrees. So we have complete triangle here. So you're supposed to be able to find D1. So what is the calculation? What is the equation to get D1 then? Raffi Gyasi. Oh, Ananda. Okay, Ananda. Yeah.
Is it 4 times 4?
Yeah.
4 times, oh yeah, cos 40. 4 times
D1 is supposed to be what?
4 times
4
cos 40
4
degrees.
times
The
yeah,
D1.
it's supposed to be 4 meters times cos 40. Yes,
Cos
right.
40. Yes.
Yeah, 4 meters times cos
Cos
40 degrees.
It's
Okay, then now
3.06.
let's we will calculate later. But now let's check what's the value just now? 3.06.
06. 06, sir.
06 meters. Okay, and we will leave it like that. Okay, now let's take a look at the small triangle. The small triangle is supposed to be like this, then like this, then like this. Okay, and the angle here is 40 degrees. Okay, the length here is supposed to be 2 meters. And the one that we want to find out is here, T2. Okay, and remember, here is 90 degrees.
Sir.
Okay, Rafi, please help me to find out what is the value of T2.
The value of D2, sir?
Hmm.
I think it's
Yeah, the equation to get the value of T2.
it'd be 2 meters times sine 40.
2 meters sine 40. Okay. Correct. And what is the value? Because I don't have calculator here. Rafi?
1 second, sir. 1.29, I think.
1.29. Yes. Okay. So now we get that T is supposed to be T1 plus T2 is supposed to be 3.06 plus 1.29. So 4.35 meters. Okay. And then we can calculate that the moment is supposed to be what? Wait. Let me check. Azer Fauzan.
Yes, sir. Hello.
We get the perpendicular distance. Yeah, we get the perpendicular distance. Now
Yes.
I want you to help me to calculate for the moment.
For the moment, okay.
What is the equation for the moment if we have the perpendicular distance?
F the force times the perpendicular
F.
distance.
Okay,
D.
F multiplied by D. What is the value of F? What's it?
The value of F is 600 newtons.
600 Newton. And the value of D is 4.35 meters. Okay, so what is the value of moment?
2,610 newtons. Newton meters.
2000. Yeah,
610 Newton meters.
and Newton meters. Let us check then how to get. Yep, correct, right? This one, although it's this is from the book is 2,610 Newton meters, but that's the way to do it. Any of you here still having a problem with this this calculation? So that's the way to find out the perpendicular distance. Sometimes we have to do it the harder way. Sometimes we won't be able to find it directly, because I believe some of you just doing it like this. Okay, this is the perpendicular distance. So just now before I discussed about it, okay, that's the perpendicular distance. So the perpendicular distance supposed to be square root of 4 square plus 2 square. It's supposed to be D like this, right? But this one is the wrong way to do it. You have to make sure that perpendicular distance is completely perpendicular to the force. So you can't just base everything from the your rough estimation. Okay, you can't do it that way. So you have to do it the proper way. Okay. Any question about this? Before I continue with the next one.
May you explain on how to get the triangles again?
How to get the triangles is I try to draw two perpendicular lines. The first perpendicular line is from the force to point O. So this one, how to get? Unfortunately, I cannot change the ink. Anyone here knows how to change the ink? Uh, the ink color.
But I
problem.
want to ask or clarify.
Wait. One by one. Just now your friend asking me first, right? So this is the first line. The first perpendicular distance. The first perpendicular line. Do you get it or not? Hello?
Which
Just now?
one, sir? I think
This
your
one.
pen wasn't moving.
Yeah, from try to take a look at this. Okay, this one.
Okay.
From the force, okay, to this.
Yes.
To O. Yeah, this one is the first perpendicular line. Correct, right? That's the length that we want to find out. But the problem is we cannot find it out directly. That's why we have to divide that into two triangles. Okay. In order to do that, I create another line. From this point, perpendicular to the previous line. So this line. Can you get it?
So sir, we are looking at the line. So it
Yeah,
doesn't have to be on the point of A.
Sorry.
Or like because before I drew the line from point O to point A, and if I take a look from your drawing, this is not on the point A itself of the line. It's actually
Point
like
A.
on the line of the force.
Oh wait. Okay, I think I need to how to okay then. Anyway, I will just draw it here. So this is the first slide. Try to take a look at this. I will redraw it here. Okay. Try to take a look closely to the top left picture. So this is the first line, perpendicular line. You get it?
Yes.
Then the second line is from this corner to perpendicular to the previous line. So it's like this. So it's parallel to the force. It's supposed to be parallel to the force, and the result is supposed to be perpendicular to the previous line. You get it?
I see. Yes, sir.
Yeah. Then this is the first triangle. Okay.
Yes.
Then
yes,
this is the second triangle. Right? You get it, right?
Yes.
Although my line is not completely perpendicular, but you're supposed to get the rough idea, right?
Yeah, sir.
Okay. So from here to here is supposed to be our T1, and from here to here is supposed to be our T2. So our perpendicular distance is supposed to be T1 plus T2. Okay?
Yes, sir. I understand. Thank you.
Yeah. No problem. If you still don't understand, please try to rewatch the video again. Okay? Because
excuse me, sir.
Yep.
I tried using at first I tried using the.
Okay. In order for me to understand you better, right? Okay. Whenever you ask question, please keep introducing yourself. So just by name, okay? This is Faisal.
My name is my name is Muhammad Faisal Fadravan. You can call me Faiz. I tried calculating it. One way was like multiplying like cos 40 times 4 times the force and adding that to 2 times sine 40 times 600, and the result is the same.
2 times.
So like
2 times
the length
wait, 2 times 2
sine
times
40.
40.
So like yeah.
Yeah, yes, of course, it will be the same. Yeah, because what you are doing is like this. Okay, both of those are the same, right? F multiplied by D is the same as F multiplied by D1 plus D2. This is mathematics. Yes, of course, it's the same. F multiplied by D1 plus F multiplied by D2. This is the things that you do just now. It's just the same, right?
Okay, I see, sir.
Yeah. So it's mathematically same. So if, but the way to do it is just like this. Okay. So it's supposed to be okay, right? I know. Now the second things that I want to discuss today is this one. Yeah, Phantom Theorem. Okay, in the Phantom Theorem, remember this one we are still talking about moment. Okay, how to calculate moment. Okay, in the Phantom Theorem, if we have a force R here, so the force is supposed to be R. This is our force R. Okay, and if the force itself can be divided into two forces, which is P and Q, where P, force P plus force Q is the same as force R. So R is supposed to be the resultant of force P and Q. Okay, in that case, okay, the moment which is caused by R to any point, in this case is point O, will be the same as the force which is caused by the moment which is caused by force P to point plus force Q to point O. So basically, like this, this one is R is moment, right? So basically, the moment is supposed to be R cross capital R. Okay, but it will be the same as R cross P. Okay, plus R cross Q. So basically, if you are confused about this, it's okay. But the basic concept is the moment which is caused by force capital R to point O or any point in the body, it will be the same as the moment which is caused by the force capital R to point O. It will be the same as the moment which is caused by force P to point O plus the moment which is caused by force Q to point O. So basically, it's like that. Okay, if you can divide the force into two, and those two forces is if you make it a resultant of those two forces, it will be the same as the previous one. Okay, the moment which is caused by the force, the resultant force, okay, will be the same as the moment which is caused by the first individual force plus the moment caused by the second individual force. So basically, it's like the concept is slightly difficult for you to understand it like that. But after this, I will try to use a example problem to explain about it. Okay. Anyone here still a bit confused about it? Anyone?
I still not really understand how can the small q have that direction in the second image. and the small p have that direction in the small in the second image. I still don't understand how can be the direction be like that.
How can be the direction? Okay.
Like the force of p and the small p have opposite direction, but q and bq and small q is not perpendicular. I still don't understand how it works.
The small q here, this one you mean?
Yes.
Yeah, that one is perpendicular actually. It's perpendicular to the line of action of the capital Q. This one, right? That's the line of action of the capital Q.
I think the Q one is the slope one beneath the one that you just give the line. I think it's my mistake to read the.
Okay. So it's so it's Q. Wait a minute. T. So it's like this. The perpendicular distance of force R, right, to point O is D, right? Because the line of action of force R is like this, right?
Yes.
Correct. So this one is the perpendicular distance. So the moment due to force R at point O is supposed to be R multiplied by D, right? If we are talking about scalar. Correct or not?
Yes. Correct.
Okay. Now, the force, the moment due to force Q to point O, what is the perpendicular distance there?
Q.
Small q.
Yes.
Small q. So M1 here is supposed to be Q multiplied by the small q. Then, what is the perpendicular distance of force P?
Force P must be P, small p. From O.
Yeah, small p. Okay. So P multiplied by small p, right?
Yes.
So that's the moment due to force P to point O, right?
Right.
Okay. Now, the definition of Ferdinand is like this. M is actually the same as M1 plus M2. This is the definition of Ferdinand, and it is conceptually correct as well. You get it?
I see.
So actually, the things that I explained just now, the idea behind it is like this.
So it looks like similar to vector.
Yes, correct.
Okay.
Sir.
Similar to vector because moment is a vector.
Okay, I see.
Moment is a vector. That's why you can do it this way as well. Okay, so
Sir,
M is equal to M1 plus M2. Yep. Who's this? Sig. Okay, Sig.
Sig. So basically, it's this is the one that like Faiz discussed just now, right? The one with the one that he discussed just now. This one.
Yeah. So basically, the basic concept that I want to talk about is this. M1 is the moment at point O due to P. Due to Q. And M2 is the moment at point O due to P. Okay. And R is the moment at point O due to M is the moment at point O due to R. Okay. If R, vector R is the same as P plus Q in vector terms, right? Then you can do it this way. That's Ferdinand theorem. Okay?
Okay, sir.
You get it?
Yes. Yes, sir.
Now, in order to make it easier for you guys, we can try to implement this to solve for the previous problem. Solve the previous problem, but using Ferdinand theorem.
Sorry, sir. I have a question. Can you go to the next slide?
Next or previous?
Yeah, this one. So
Okay, this one
it is
you're
stated.
supposed to tell me that this one is not next, but previous.
Oh, sorry. So this is stated that the moment is minus for the P1 and positive for the Q1. Is it because
Okay. Sorry. This one I just added because I didn't count for the plus and minus. It's supposed to be in this case I made a mistake. Okay. In this case, clockwise we call clockwise as plus because there's supposed to be direction. So clockwise here is supposed to be plus. So this one is plus.
so it's not the
R
same as
and
torque,
D.
yeah, sir?
Yeah, the same. Clockwise, we have to assume the positive and the negative direction. So here,
clockwise
yep.
is positive and anti-clockwise
Yeah,
is negative.
that's my assumption. Yeah, so you have to assume it first.
Oh,
like this. So plus is clockwise then in this case. Okay, when we assume it like this, then M here is supposed to be plus. Then M1 here, the value is supposed to be Q is supposed to be plus as well, right? Then M2, nah, that's the problem. M2 here, because the the perpendicular distance P is there, and the force is here. So the moment which will be caused by P will be counterclockwise, right? Correct or not?
yes, sir. I'm
in that
used
case, it's negative.
to thinking that counterclockwise is positive.
No, it's up to you.
Oh, it's up
But
to me.
you have to define from the beginning which one is positive, which one is negative.
Oh, okay.
So here the definition that I defined from the beginning is positive clockwise. So M2 here is negative. The value is negative. So I will just do it again. M2 is equal to minus P multiplied by P, right? But at the end, just sum all the moment. But remember here, the value here is supposed to be negative, right? If you sum something with negative, it's the same as a subtraction, Matthew. Correct or not, Matthew?
Yes, I understood, sir. Thank you.
Yeah. So M2 there is negative because the direction is negative. Yeah.
Sir. To determine the positive or negative, it is dari R-nya kan, Pak? We look from the R.
Yes, correct. Actually, yeah, from the R or from the in the scalar fashion, right? Is from the perpendicular distance. So the easiest way is always from the perpendicular distance. So just think about it. The first thing, the first thing that you're supposed to do is this one. Determine first which direction that you want to assume as positive. You want to do it clockwise or counterclockwise? Positive. Any direction is okay. Okay. Then after you assume it like that, then try to be consistent. Just now I didn't do that. So that's why I made mistakes. Thank you for Matthew to correct me. Okay. Because of that, I determined that clockwise direction is positive. The perpendicular the force R here will cause clockwise movement, so it's positive. The force Q will cause clockwise movement as well. That's why it's positive. The force P will cause counterclockwise movement. That's why it's negative. That's why I put here it's negative. Okay. Just now, who want to ask question? Risky or what?
Yes, sir.
Huh?
So,
Irfan,
what's
yes.
the difference what's the difference between the formula right now and the given equation on the picture? Because it's written plus QD and not big Q and small q.
This one is wrong.
Oh,
This
so
one is wrong.
it's
It's
wrong
supposed
formula.
to be Q. this one is supposed to be Q, small q.
Okay.
So
Okay,
it's
sir.
supposed to be minus capital P multiplied by small p plus capital Q multiplied by small q. That one is
Yes,
wrong.
sir. Thank you.
Thank you for correcting me. Yeah.
Sorry, sir, for interrupting.
I
wanna
think in
ask.
order from sorry, I cannot hear your voice clearly. Who's
Sorry.
this?
I'm Sunita, sir.
Yeah, yeah.
I wanna ask why. Can you replay why the P-force is counterclockwise?
P force is no, not P force, but the moment
Yeah, P.
which is caused by P
Yes.
force P,
Mm.
it will be counterclockwise.
Why
Yep.
is that?
Wait. Let me fix something first because next time I don't want to make the same mistake. Q, yeah. Control C, Control V, Q. Okay. Okay. Why P force? Why moment due to P is counterclockwise? Okay. In that case, I will redraw again. Okay, in order to make it clearer. Okay, so this is just now the body, and this is point O, right? Correct or not? Hello? Hello? Who's asking me just now? Why suddenly the voice is missing? Hello? Can you guys hear my voice?
Yes, I can, sir.
Yes, sir.
Who's asking me just now? Sunita?
Yes, sir. Sunita.
Okay, Sunita, don't turn off your mic because I need your response. Okay,
sir.
Okay, so it's like this, right? Then at point B here, there is a force R, and then there is the force R can be divided into two, Q, and the other one is P. This one is R. So remember that this one is a vector. So R is supposed to be P plus Q, but it's in vector term. Okay, and then this is the distance. Okay, now your question is after we divide the force into two, P and Q. Okay, why the force due to the moment due to P will cause counterclockwise, right, Sunita?
Yes, sir.
So do you understand why the force due to R and Q is clockwise?
Yes, yeah, I understand that, but I don't understand why the P is counterclockwise.
Okay. So you have to take a look at the line of action. So this is the line of action of force P, right?
Yes.
Okay. And this is the perpendicular distance, right?
Okay. Okay.
Right? That's the perpendicular distance. Okay. Try to imagine in your brain. Try to imagine if this is the case. Okay. The movement due to force P to point O will be counterclockwise or clockwise. Can you imagine that? The moment arm is like that. You can see it. Can you see my video?
Yes, I can.
This one. Yeah. The force is going up, right?
Oh, yes.
This is point O. This is point O. Okay. This is point O, and this is this is this particular point. Okay. So the force is going up. Can you imagine the movement? It's supposed to be like this, right?
Oh, yes. I can imagine.
Supposed to be counterclockwise, right?
Yes.
Yeah. That's the thing.
Okay.
You get it right now. Now,
I get it.
I want to make sure that you understand, completely understand. Now, take a look at point for start. This is the line of action. Okay, and this is the perpendicular distance, supposed to be the perpendicular distance, right?
Yes, sir.
Okay.
Hmm.
Now, this one is the force, and this one is the perpendicular distance. Okay, you can see, right? The movement is supposed to be clockwise, right?
Yes, sir.
Sunita?
Yes, yeah.
So that's the way to imagine about it. Okay, you get it, right?
Okay. Yes, I get it, sir. Thank you.
Good. Okay, now let's try to use our let's try to use the Phantom Theorem to solve for this one. Okay, let's use Phantom Theorem to solve for this one. Nia Aulia.
Yes, sir.
Okay, can you help me to do so? What we're supposed to do in order to use Phantom Theorem to solve for this? The same, the previous problem that we already solved. Oh, you need sometimes to some time to think about it. Hello, Nia?
Yes.
Do you need time to think about it?
Yeah.
Yeah, okay then. I think for all of you, please try to solve this by using Phantom Theorem. The same problem as before, but using Phantom Theorem. And I will give you guys 5 minutes to do so. And after that, we will discuss about it. Okay? Okay, guys? I need your
Okay,
response.
Pak. Okay.
Okay, sir.
Good.
Okay, sir.
Okay, as usual, I will stop. I will pause the recording. Okay, and I will get back to you in 5 minutes. Okay, have you got it, guys? Hello?
Yes, sir.
Yes, sir.
Okay. Sorry for the distraction here. Okay, I told you that about the problem I had. Okay. Just now I asked Nia, right?
Yes, sir.
Okay. So Nia, how we should solve these problems, Nia, using Phantom Theorem?
Made a triangle. Sorry, can I speak in bahasa? Cause I a little bit difficult.
It's okay. Yeah. Gimana?
Jadi tarik garis dari titik A ke O.
Terus?
Terus?
Tapi ini bukan Phantom Theorem. Kalau Phantom Theorem itu kan harusnya gayanya dipisah jadi dua, ya.
Ya. Gayanya dipisah jadi dua. Itu kayak diproyeksiin gitu kan?
Ya, betul.
Terhadap sumbu X itu aku misalin jadi Fx.
Oke, jadi seperti ini ya, ada satu gaya seperti ini,
ya.
Fx, lalu terhadap sumbu Y ada Fy. Oke. Nilai Fx dan Fy bisa dicari, gitu kan ya?
Ya.
Fx nilainya berapa?
Fx itu 600 kali cos 40 derajat.
Nah, harganya nanti aja. Saya cuma mengecek caranya saja, oke? Berarti Fx itu sama dengan 600 Newton dikali. Saya mix pakai bahasa Inggris ya nih ya. Okay. So Fx is supposed to be 600 Newton cos 40 degrees. Then Fy is equal to 600 Newton multiplied by sin 40 degrees. 40 degrees. Okay. Then what should we do after that? You can explain in bahasa.
Kalau yang fx itu fx tarik garis ke bawah, terus sambung ke titik O. Jadi ngebentuk
X
ya.
tarik garis.
Dari FY tarik garis ke bawah.
FY atau FX?
FY.
Oh, FY kembali kamu tadi ya berarti ya. FY.
Ya, tarik ke bawah.
FY tarik garis ke bawah. Oke.
Nah.
So this is the perpendicular distance.
Ya, terus segitiganya itu tarik garis dari O ke A.
O ke A. Segitiga itu?
Titik, ya segitiga gitu.
Oh, nggak perlu buat segitiga.
Oh, nggak perlu.
Kalau ini nggak perlu. Jadi coba lihat ya. Oke, can you see this?
Oh, iya.
FY, the line of action of FY is supposed to be like this, right? So this is, this horizontal line, this one is supposed to be, I will call it as my X, okay? The X here is supposed to be our perpendicular distance for F1. Do you get it?
Yes.
And then this one. This is the perpendicular, this is the line of action of Fx. Right? Yeah. And this one, I will call it as Y. Okay, this distance, right? This distance, I will call it as Y. And that one is supposed to be the perpendicular distance for Fx. So moment due to Fx is supposed to be Fx multiplied by Y, and moment due to Fy is Fy multiplied by what?
X.
Like that. And the total moment is supposed to be moment due to Fx plus the moment due to Fy. Do you get it, Nia?
Yes.
Yeah. Okay. Fx here, replace it with this value. Fy here, replace it with that value. Okay. The value of x here, the x distance here is supposed to be what? Yeah. The value is there actually. Huh? The x distance here, what is the value of x distance here?
It's 2.
2 meters, yes. The value of y distance is supposed to be 4 meters. So we get all the value there. So we will be able to find the moment using the Phantom Theorem. And the calculation is supposed to be the same. Sorry, the value is supposed to be the same. Let's check, okay? Okay, so the value is the same, supposed to be the same. You get it?
Yes, I get it.
So whatever way you use, the moment, even though you use a Phantom Theorem or you use the previous one, perpendicular distance, the result is supposed to be the same. Okay? Yeah, thank you, Nick. Okay, you're supposed to be get all the points here, right? Get all the important points here, right? You understand completely, right? Yeah.
Yes, sir.
Okay, good. Anyone here wants to ask question about the Phantom Theorem?
Sir, I want to ask. I calculate differently with you, but I got the same result. But
which one is calculating? You calculate.
So in here, the F1 in the slide you use 600 cos 40. And it is times by 4, yeah.
F600 cos 40 x, you mean? Fx here multiplied by y, yes, correct.
Yeah, I mean in before you fx wait. Oh, never mind. I think I got the wrong impression. Sorry.
Okay. Okay. Anyone else want to ask question?
Excuse me, sir.
Okay, William.
So as if there always made a 19 degree for the penjabaran of the fs and fy, or it may be
the simplification is better that way, because that's the simplest way to do. For me, instead of dividing the force into other angle besides 90 degrees, I always prefer to use 90 degrees because normally it will solve the problem. Because, okay, remember, right? If we use the, if we have to use the unit forces as well, okay, unit forces as well, unit vectors as well, okay, it is better for us to divide it into x, y, and z, right? Always that way.
Oh,
And
okay, sir.
and in the next session as well, in the next chapter as well, we always divide the force into fx, fy, and fz if it's in a three-dimensional case. But in two-dimensional, we always divide it into fx and fy. Always there. Because that's the simplest way to do it.
Oh,
Okay,
okay,
William?
sir.
Yeah, it's a good question. I believe you are asking me like that because in the previous one, in the previous case that I told you guys here is the P and Q is not 90 degrees, right? But this one is the general form for Ferrignam theorem. But the simplest way to use Ferrignam theorem is by using 90 degrees divided into fx, f1, or fz in three-dimensional. Okay, good.
Yes, sir. Thank you, sir.
I think in that case, I will continue. Okay, the next one that we will talk about is a couple. Okay, the same as couple in the real world. Okay, couple here is although here is a couple is not a real couple like a guy and a girl like that. Okay, but this one is a forced couple. So the forced couple that we are talking about here is a condition where we have two forces which has exactly the same magnitude but opposite direction. Okay, exactly the same magnitude. Okay, but opposite direction, and they are parallel to each other. Parallel to each other. So there must be a distance there. Then the magnitude is the same, but exactly in the opposite direction. We call that kind of forces as force couple, or just we can just call it as couple. Okay. What's so special about this couple is whatever point, wherever you calculate the moment which is caused by those two forces, it will be exactly the same. It will be exactly the same. What I mean is, okay, the first thing is I want to calculate, for example, I want to calculate the moment which is caused by those two forces at point O. Okay, at point O. Okay, let's try it. Okay, in that case, the moment due to the minus force is supposed to be clockwise, right? Okay, in this case, I will try to make different assumption. Counterclockwise positive. Okay, counterclockwise positive. Then I will use the minus f first. Okay, so there is a f, but the direction is in this direction, and the distance there is a. Okay, Ananda Asar.
Yes, sir.
Okay, for that minus f force, the moment which will be caused by that force at point O will be clockwise or counterclockwise.
The minus, right? Yeah, sir.
Yeah, the minus one. The minus
one. I'm sorry. Which? Oh, the line. Yeah, the line. Yeah.
Yeah. The minus force. This one. Okay.
Yes.
I'm asking you the moment which will be caused by this particular force
Clockwise.
at point O, clockwise. Okay.
Yes.
If I assume that counterclockwise is positive, then the value is supposed to be minus, right?
Yes.
Okay, so it's minus F multiplied by
D.
what is the perpendicular distance?
A. It's A.
Okay. Then, because I want to calculate the total moment, so I will try to find out the moment which is caused by the plus F as well. Okay, Ananda sir,
Yes.
I believe you knows your friends quite well already because you already interacting with them for one semester, although online. Please
Yes.
pick one of your friends to help you to answer this. To help me to answer this.
But before that, can I ask? Before that, can I ask something?
Okay then. Yeah.
Can it be the moment equal to minus F times 2D because D and A is perpendicular to minus F? Can we use D as well?
Yes, of course. We can use D as well.
Okay.
Oh, you want to answer it? Okay then. What is the force which is the moment which is caused by the plus F force at point O?
Pardon me. Can you say yes?
Yeah. So just now I want to find out the moment due to both of these forces at point O, right? Just now Ananda Azhar already helped me to find out the first moment.
Okay.
Now I want you to help me to find out the second moment due to plus F at point O.
Is it the same but the F is positive?
Yeah, F is positive, then
times D.
D, only D. Remember, the
D
center
plus
of
A, D plus A.
Okay. A plus D, okay. And what is the direction?
The direction is
clockwise or counterclockwise?
Counterclockwise.
Counterclockwise. If I assume counterclockwise is positive from the beginning, then the value is supposed to be positive or negative.
Yes, positive.
Okay, so it's correct. Then the total moment is supposed to be
M1 plus M2.
How to get to this? Supposed to be M1 plus M2. Okay, so the total moment is supposed to be M1 plus M2. In this case, is supposed to be minus F multiplied by A plus F A plus D.
Yes.
Okay, help me, Rizky, to simplify this.
So, so the FA can be cancelled out.
Okay,
so it will be FD only.
FD only. So the total moment will be FD, right?
Yes.
Total moment at point O will be FD. Now, I want you to calculate, Rizky in that case. Please help me to find, to choose your friend to help me to answer this.
Okay, I would like to choose.
Oh, because there are so many guys in the class, I want you to choose a girl right now.
A girls.
A girl.
Okay, wait. I don't know many girls in here. Maybe.
Just one.
Meryl.
Meryl already answered my question before. The one that hasn't speak at all today.
Sule.
Sule? Who's Sule?
I think he meant Rayhana, sir.
Rehana Sule.
Oh, Rehana.
Yes, sir.
Anaknya Sule, Pak.
Oh.
No, it's not.
Rehana, wait, because I need to see which one is Rehana. Okay, Rehana. Okay,
Yes,
Rehana. Now, the same case here. Okay, then here. The same case here. O, we have just now we have O. We have F, right? But actually, it's the same body as before. Okay, the same body as before. Okay, we have F here. We have minus F there, we have F here, F minus F, and but I want you to find out if there is a point here.
If there's a what?
Point where I want to find out the moment. Okay, and there is the distance here is t, the same as before, but the location where I want to find out the moment is here actually, exactly at the location of force minus F. Okay, do you get it or not, Rehna?
No, I don't quite get it because the line is too small.
Okay, then in that case, I will withdraw it again. This is the body just now, and this is point O, and there is a minus F here, and then plus F here. Okay, F. I will just put it as F. Then we have the perpendicular distance, right? Okay, the perpendicular distance from here to here just now is here. Okay. Okay, the perpendicular distance there is A and D. Okay, here is A, this one is D. Okay, the previous problem, we solved for the moment at point O, right, Hannah?
Yeah.
Okay, now I create another point here, exactly at the line of action of this particular force. Okay, I call the point as C, point C. Okay, now I want you to find out the moment due to both of these forces at point C.
Okay, the force that acting to the left side, I will call it as min F. And because it's on in the direct C, so I guess it's 0. It has 0.
So supposed to be 0, then
FD plus
then FD. If I assume that same as before, counterclockwise is positive, FD is clockwise or counterclockwise?
Yeah.
Sorry, this one. The moment due to this is clockwise or counterclockwise?
It's clockwise.
Clockwise? You sure?
Anti-clockwise.
Don't change because I.
No, I said that the F that acting towards the C directly, it's minus F.
Okay, so this one, right? This one is minus F, yes. But this one will cause no moment, right? Because it's exactly in the line of action. So the moment is 0, right?
Yes.
Okay, but how about this one?
It's anti-clockwise.
Anti-clockwise, and the value is?
FD.
FD, not clockwise, okay? Anti-clockwise.
Yes.
Because it will give a rotation like this, right?
Yes.
Yeah, so FD. Compare it with the previous one. Hannah, the previous one, the moment at point O, okay? The previous one, the moment at point O is the same, FD. Right?
Yeah.
So actually, if you have a couple, this is for everybody, okay? If you have a couple, wherever the point is, wherever the center of rotation is, okay, at point C, at point E, for example, G, H, like that, whatever the point is, wherever the center of rotation is in the body, okay, the moment which will be caused by those two forces, this couple, okay, will be exactly the same. And the value of the moment which will be caused by the couple to any point of the body will be the same as force just one, okay, just one value of the force, the F, the value of F multiplied by D, where D is the perpendicular distance between both forces. Do you get it, Raihana?
Yes, I get it.
How about the other? So the moment will be exactly the same, just F multiplied by D, wherever the location is. Wherever the location of the center of rotation is, wherever the center of rotation is.
Okay, sir.
Okay, good. I want to ask again, Asha.
Yes, sir.
You get it, Pasha?
Yes, sir.
How about you, Irfan? Do you get it?
Yes, sir. But I have a question.
Yep.
One question.
What is the question?
About the rotation. Sir, what do they mean by that in the figure before, in the slide before, sir?
Slide before. Just okay.
Oh, is it the direction or what for the M, sir?
Sorry, the direction or the,
yeah, for the M in the figure. What does that represent?
Which figure? Which one? The bottom one? You mean this one?
The upper one, sir.
Upper.
Where there is a direction upwards, the M.
Oh, you mean this one?
Yes.
Okay. Oh, that's supposed to be the direction of the rotation, actually.
Oh, so I mean, like,
but
why is it going upwards, sir?
actually, you don't have to take a look at this. Okay, you don't have to take a look at this because you don't have to take a look at this. Just try to understand from my explanation before. Do you get it from my explanation before? Yeah.
Yes, sir. Yeah.
Okay. Now let's try with this one. This is supposed to be our last class discussion about couple. Okay. Now I'm asking you. Try to read this problem, and then we can discuss it fast. Then we will end the class. Okay. Who has an answer? Okay, I think Fasadiara.
Yes, sir.
Okay, Fasa. Do you understand about the problem here?
Sorry. I'm still trying to understand.
Okay. So I will explain it to you and to all of you guys. Okay, but don't turn off your mic because I need to because we have to finish this fast. We only have 5 minutes to discuss about it. Okay. The F here.
Okay.
Okay. The F here. Each of those F. Okay. Has a value of 300 kilonewton.
Okay.
Okay. Then the question is, what is the moment which will be caused by those two Fs, this couple, okay? And then what are the forces which have to be produced by these two ship, okay? In order to counteract the moment which is caused by this couple. So that's the whole question. Do you get the question or not, Asadira?
Yes.
Okay, I think it's better for us to answer it one by one. The first question first. Okay, the moment which is caused by this couple. The moment which is caused by the first couple. The 300 Newton to 300 Newton forces. What is the moment which will be caused by those two forces? Pasadira.
300
300
times
kilonewton,
12,
okay. Times
12.
Times 12 meters. Right? That's simple. So it's supposed to be, what is the value there? 3,600 kilonewton meter. Right?
Right.
Okay. Then the moment here is clockwise or counterclockwise? Take a look at the forces there. Try to imagine the force. Clockwise or counterclockwise?
Counterclockwise.
Are you sure counterclockwise?
No.
The F here is going to the right and the other F is going to the left. So the rotation will be like this, right? If we can imagine the rotation, it will be like this, right? So it will be clockwise actually. Why they will there? Okay, it will be clockwise, right?
Yeah.
Do you get it right now, Pasadira? How to determine whether it's clockwise or counterclockwise?
Yeah, I get it.
Okay, so this one is clockwise. Okay, the force there, the moment there, 3,600 kilonewton meter will be clockwise, right? And now, what is the force resistance there? Wait. So sorry for the distraction. Okay. Now, the next question, Pasadira. What are the forces which has to be produced by these two boats in order to contract the moment there? Pasadira. You get it or not? The boat here actually is pushing pushing the big boat, the small boat, okay? The small boat is pushing the big boat. So actually it will produce a force here. The same as this one. It will produce a force in the direction of the boat like that. Do you get it or not?
Yes, I get it. So I think it's 120 minus 50.
Okay, so the distance here is supposed to be 120 minus yeah. So it's supposed to be 70, right?
Yes, 70 meters.
Yeah, 70 meters. So the distance is supposed to be, the distance is 70 meters multiplied by the forces, right?
The force. Yes.
Yeah, so we call it as a P. This one is P as well, right?
Yes.
Okay, so multiply by P. And the value is supposed to be what?
The value supposed to be 3,600.
Yes, correct. 3,600 kilonewton meters. Yeah. So P here is supposed to be 3,600 kilonewton meter divided by 70 meters. Okay, so we will be able to get it. Can you help me to calculate for this? 3,600 divided by 70.
51.4.
51.4 kilonewton. So this is it. That's the thrust P, which is supposed to be produced by each boat. And this moment, which will be caused by this force P, okay, due to each the first P there, it will be contracting with the first moment, because the first moment will be clockwise, and the moment due to P couple, the first P couple will be counterclockwise, like that. Okay, you understand, right?
Okay.
Yeah, good.
Yeah, I understand.
I think that's all discussion for today. Okay. I believe by today, I will post homework. I will post a homework in the MS Team, and the deadline for the homework will be uh, next Thursday. Next Thursday before class. Next Thursday before class. So later, my assistant will put the submission link in the MS Team as well. Okay, so you can submit it there before the deadline. Okay. Any question about the homework? Any question before I close the class? Supposed to be okay, right?
Will there be collaborative learning this Saturday?
I'm not sure about it. You're supposed to ask in the big class, the big MS Team class, because Pak Ferry is the one who decide everything there. Okay.
Okay.
Sir, I'm sorry, I want to ask. I still don't understand where you get the 3,600. What times what? I
Oh,
still...
3,600 kilonewtons comes from 300
Oh,
kilonewton
the
multiplied by the
times.
distance, just 12 meters.
Oh, I see.
Yeah, it's F multiplied by D, right? Remember, the moment which is caused by the couple is F multiplied by D. D is the distance, perpendicular distance between the couple forces. Remember about that, right?
I see.
The same as this one as well. The P multiplied by D is the couple. So actually, this problem is actually we have two couples. The first couple is F couples. The second couple is P couples. Okay, the F couple will give you clockwise moment. The P couple will give you counterclockwise moment, and it's supposed to be in balance condition. That's all. That's why we do it this way. Okay.
So the force is for each thrust.
Yeah, right. So F, its F is 300 kilonewton, and each P is supposed to be, after we calculate everything, each P is supposed to be 51.4 kilonewton. Okay.
Okay, sir. Thank you.
Good. And then I think it's already 9 o'clock, and I don't want to exceed the time limit. And I think that's all for today. Okay. Thank you for listening, and see you guys on next Thursday. Okay. Don't
Terima kasih,
forget
Pak.
to do the homework. Okay. Okay then. Yeah. Bye bye.
Thank you, sir.
Yep.
Thank you, sir.
Thank you, sir.
Thank you, sir.
You.
Thank you, sir.
Okay. Bye bye.